Okay, so today we are going to talk a little bit about quadratic graphs and kind of the different things that change when we're looking at it. So our standard form of a quadratic is going to be ax squared plus bx plus c. Okay. A is always going to be the term that we're talking about in front of this x squared. B is always going to be the term in front of just the x, and then c is always going to be that term on the constant. Okay. And you can see over here on this graph we have our standard form of y equals ax squared plus bx plus c. Okay, and then I have letters on here so that we can change these numbers so that we can see what happens with this graph every time that we change a number. So you can see right here our a value is 1, okay, c is 0, and b is what we're looking at is just the graph of y equals x squared. Okay, this is what we call our parent function. This is what it looks like just any kind of normal time. So the first thing that we're going to look at is graph direction. Okay, so you'll notice that this is a U shape. Right, we call that a parabola. Okay, and the direction is going to be determined by A. So you can see right now it is a positive 1, right? And if I slide this staying positive, that graph is still facing in the same direction. Now if I slide this A value back to the left, right, as soon as we get negative, you'll see that it flips upside down. Right, so if we have a positive A value, our graph would look like this. Now it could be in a different spot on the graph, but it's always going to be opening up like a U. If we have a negative A value, right, it is going to be upside down, right, or like an N. Okay, so this A value, right, is going to determine the direction of the graph. Whenever we look at an equation of a quadratic, we should be able to tell which direction it's going in. So for example, if we have these two, this one has a positive A, so we know our graph is going to look something like this. This one has a negative A, which means it's going to look something like that. Right, all that from the beginning. The other thing that we can look at is, you'll notice how sometimes the graph is skinnier, right, or it might get wider. Okay, when we start with our normal parent function, right, at 1. Now, if the absolute value of A is greater than 1, which really just means any number to the right of 1, so you see like 6.2, right, or to the left of negative 1s, like negative 2.5, you'll notice the bigger those absolute values get, the skinnier the graph gets. A value increases, right, or goes farther than 1, right, you'll notice that it's getting skinnier, whether it's in the negative direction or the positive direction. And that's because as we get to a bigger value, it's making that graph jump farther, right, in a smaller amount of time. It's kind of like slope. It's making it steeper, so it's going to go quicker. Now, if we get between negative 1 and 1, you'll notice that's when we have those wider graphs than our parent function. So for absolute less than 1, it's going to make the graph wider. So that's what our A value is going to tell us about this graph, right? It's going to tell us the direction as well as if it's going to be skinnier are wider. And next we're going to look at C value, which is this constant over here at the end. You'll notice right now it's at 0. Okay, but start to shift this to a bigger C value, right? You might notice that as C increases, right, this graph is shifting up. Okay, or as it decreases, it moves down. So that C value is going to shift the graph up or down. Okay. It's also going to be our y-intercept. Okay, so a positive C moves the graph up. And a negative C moves the graph down. Right? So when we're looking at a quadratic equation, right, we can tell, is the graph going to be facing up or down? Is it going to be wider or skinnier? We can also see just by looking at this value at the end, right, is it going to move that graph up or down? So this one right here has a negative C value. It's a -4. So that's going to move that graph down. Right? It's going to shift it down, and we know that the y-intercept is going to be -4. This one has a +8 at the end, which means that it's going to shift that graph up 8. Okay? The y-intercept is also going to be at +8. So then the last thing to look at is the B value, and you might notice right here when B is 0, our graph is kind of centered right here on this y-axis. Well, as we change our B value, right, that's going to start moving that graph left or right. Okay, so that B value is kind of what's going to help us determine where this center line is on the graph. Okay, and so when we're looking at that center line is called our axis of symmetry. And it's a line that goes right through the middle, right? So when B was 0, right, we were right here in the middle, so this y-axis, okay, is our axis of symmetry, but it's still a line that's going vertical up and down. So remember, whenever we talk about a line that's vertical, the equation of that is always x equals. And how we find that is by doing -b over 2a. So our axis of symmetry is always going to be -b over 2a. So if we look at this example, the axis of symmetry is going to be -b. So this value right here with the x, we're going to take the negative of it, so -3 over 2 times a. So it's going to be at -3/4. So if we were to look at that graph, a was 2, c was -4, and b was 3. If we were to kind of zoom in on it and look at where the middle is, you can see it is at -3/4. Right? So right through here is where that axis of symmetry is, which is -3/4, which is exactly what our equation told us. So our axis of symmetry goes through this point, which is the middle point, and that's called the vertex. So that's our middle point of the graph. Okay, it's either going to be the highest point on the graph or the lowest point on the graph. In this case, since our graph is going up, right, this is our lowest point of the graph, and that is the x value of your vertex is always going to be your axis of symmetry, so that's negative b over 2a. And then to find your y value, well, this is a function, so you would take you get here, so 3/4, and we would plug that back in to our function, so that we'll call it f of negative b over 2a. So this is the x value from our axis of symmetry, and this is what you get when you plug that number back in to the equation. So these are kind of the basics of when we're looking at a quadratic equation, right, and how to determine some of the different shifts that parts of the equation will make on the graph, as well as being able to find the axis of symmetry and the vertex.